Good day and welcome to Math 111H Calculus 1 Honors, The Joys of X. Today we're going to discuss the difference between average and instantaneous slope. As we see in the figure, there's a curve, a black curve, that goes from A to B. The rate of change as we go from A to B, the average rate of change that is the slope of the line, the blue line, from A to B. That is y at B minus y at A divided by x at B minus x at A. Gives the average rate of change of the curve as we've gone from A to B. As we move down the curve, we get a different secant line, for example, from A to C, which gives the average rate of change along the black curve from A to C. As we move further and further down the line, closer toward A, we get closer to what we call the instantaneous rate of change. That is the slope of the curve exactly at the point A. That's represented here by the red line from A to D. This concept comes up every day in terms of velocity. Suppose you travel 200 miles in a straight line in 4 hours. Your average velocity is 50 miles per hour. However, it's unlikely that you were traveling at exactly the speed of 50 miles per hour at every instant during your trip. In particular, you were likely traveling with an instantaneous velocity of 0 at the very start and a 0 velocity at the very end. And in the middle, you might have been going faster than 50 miles per hour. So that represents the difference between the average velocity and the instantaneous velocity, which is what you see on your speedometer in your car. Another example, we could consider the function y equals f of x from 1, x equal 1, to x equal 2. So the curve goes from 1, 1 to 2, 4. The average rate of change from 1, 1 to 2, 4 is the change in y divided by the change in x. Y of 2 minus y of 1 divided by 2 minus 1, which is equal to 3. That's the rate at which the curve is going on average as you go from 1, 1 to 2, 4. Now, if you go from 1, 1 to just any point on the curve, say x squared, we get y at x minus y at 1 divided by x minus 1. So we get x squared minus 1 squared divided by x minus 1. We can factor and we get x plus 1. This is all right to do everywhere except where x equals 1 because the denominator would be 0. However, as we move down the curve y equals x squared, as we get closer and closer to 1, 1, we find that the slope is still x plus 1 everywhere that x is not equal to 1. So as x gets closer and closer to 1, the slope becomes very, very close to 2. And so we find that the instantaneous slope at x equal 1, y equal 1, is equal to the x value plus 1, which is 2. Let's take a moment for some math culture. We could discuss the problem of how can you tell the difference between a physicist, an engineer, and a mathematician. Well, if each of them were in a hotel room and woke up to see that the blanket had caught fire, what would they do? The physicist would get up, check his books, perform a precise series of calculations, and return with a glass of water. The glass would contain exactly enough water to put out the fire, yet be totally evaporated so the physicist could return to bed with a dry, albeit scorched blanket. The engineer would fill the glass, put out the fire, and return to sleep in a soggy bed. The mathematician would open one eye, glance toward the bathroom, see the faucet and the glass, and would think to himself, a solution exists, and go back to sleep. Thank you for joining us today. Have a great day, and may the power of math be with you.